Hi class, welcome to our fifth lesson on circles, 10.5. We're talking about tangents today. Going to do something a little bit different. Here's the completed circle book page for 10.5. So open up your fifth page in your circle book and copy this down, everything. This is everything that's required of you for your fifth circle page. So please write that down, pause the video, and then I'll explain everything after you write everything down. Now that you are ready to go, you have everything on your circle book. Let's first talk about what a tangent line is, being that it's titled 10.5 tangents. A tangent line, it touches the circle at only one point. So this line right here is not a tangent line. It touches it twice. This line here is not a tangent line. It doesn't touch it at all. However, this line right there is a tangent line. It touches the circle at one and only one point. That's what a tangent line is. Now, for a tangent line and a radius, that relationship, a radius is always perpendicular to a tangent line. So if a radius and a tangent line intersect, that intersection is always going to be 90 degrees or a right angle. Okay? That's the first property here in our 10.5 notes. The second property is if two segments are tangent and they share a common endpoint, then they are going to be congruent. So if this is 7 feet long and it's tangent to the circle at that point, and this line right here is tangent to that point, and they have a common endpoint, then those two segments are going to be congruent. They're both going to be 7 feet long. And that completes our properties for our circle book today. So now we're just going to be doing some examples. So you could take out your notes packet. And the first question, if segment RS is tangent to circle O at point R, find Y. So if we know that SR is tangent, and we know QR is a radius, well, a tangent line and a radius are always perpendicular. So that angle is 90. So now I can at least find the radius of the circle. The radius of the circle is this green line that I drew. I'm going to call that X. I could find the radius of my circle because I have a right triangle with the radius and the tangent line being perpendicular. 20 is my hypotenuse. So 20 squared is going to go on the right side of the Pythagorean theorem, and then x squared and 16 squared go on the left side of the Pythagorean theorem. And let's solve for x, which is going to be my radius. X squared plus 256 equals 400. Subtract 256, x squared equals 144. So my radius is the square root of 144, so x equals 12. So if QR is 12, which is a radius, PY, or PQ rather, sorry, is also 12, because every radius is congruent in a circle. So that means my y, which is the diameter, y equals 12 plus 12, which is 24 units. Next one is BC tangent. If this segment, BC, is tangent, then it touches at one and only one spot. Well, you can't really tell, and you can't always go by what it looks like. Let's see how else we could see if it's tangent. AB is a radius. Would you agree that AB is a radius? So if AB is a radius and a tangent line are always perpendicular. So the question is that 90 degrees? In chapter 7, we learned that if a triangle is 90 degrees, then a squared plus b squared equals c squared. So if we want to see, to answer this question, is segment BC tangent, we would need to see, does a squared plus b squared equal c squared? Okay? So the two legs are 7 and 9. 7 squared plus 9 squared, does that equal the hypotenuse squared? The hypotenuse is 7 and 7, which make 14. Now we're not saying that it is, we're asking ourselves the question. If a squared plus b squared equals c squared, if that does work, then it is tangent. If the left side does not equal the right side, then it's not tangent. Let's take a look. Does 49 plus 81 equal 196? 49 plus 81 is 130. Does 130 equal 196? Absolutely not. Is BC tangent? The answer is no. This angle right here is not 90 degrees, because if it was 90 degrees, then BC would be tangent, but it is not. Why don't you guys pause the video and why don't you try this one on your own? as you tried this one, if WE is tangent, you said that 26 squared equals the two legs, 10 and 24 squared. And then when you did this, you got 676, I think, equals 676. Just let me look at my notes and see if that's right. Yes, 676 equals 676. So the answer is yes. Okay, if we're looking at this one, this is our second property that we talked about in this lesson, where if two segments are tangent and share a common endpoint, then those two segments are congruent. So we see that ED is tangent and FD is tangent. So they share a common endpoint, and that common endpoint is D. So just knowing that, we could say we know what y equals 10. Y equals 10. Our instructions are to find x. Now, we're also given that GD and HD are also tangent lines that have a common endpoint. So if I think about the length of segment GD, it is 10 plus y minus 5. So it would be y plus 5. If you take y minus 5 and add 10, then you would get y plus 5. Shoot. I don't know what I was thinking there. I'm sorry. We already know what y is, right? Y is 10. So we could substitute 10 into that y. And so segment GE is 5 units. And so what's the length of segment GD? GD is 5 plus 10, which is 15. 15 units equals the same length as DH, right? And DH, how long is DH? If we know that FD is 10 units, what is 10 plus x plus 4? That would be x plus 14. There we have it. So one segment GD is 15 units. Another segment DH is x plus 14. They're congruent to each other because they're both tangent lines that share a common endpoint. So now we're going to solve for x. Subtract 14 from both sides, and clearly x equals 1. So my solution for this one, find the value of x. The value of x equals 1. Last one that we have for today, again, dealing with the same concept where when two tangent lines share a common endpoint, those two tangent lines are congruent. So JM is 16 units long. JL is also tangent, and it shares a common endpoint. So JL, that segment, is also 16 units long. HL, 18 units long. HN, also tangent, shares a common endpoint, 18 units long. I want to find the perimeter of this triangle. To find the perimeter, I need to know all three sides of the triangle. I don't know what MK is, and I don't know what NK is, but I do know that they're congruent to each other because they're both tangent lines that share a common endpoint. So NK, that equals JL plus 29. JL is 16, isn't it? So it is 16 plus 29. 16 plus 29 is 45. So now that I know that NK is 45, I also know that MK is also 45 because they're congruent. All right, what is the perimeter of this triangle? This leg plus this leg plus this leg. All three sides of the triangle added up together. So it is basically two 18s, two 16s, and two 45s added up together, right? It's each and every one of those segments. 16 plus 16, 18 plus 18, 45 plus 45. And that sum is a whopping 158 units. The perimeter equals 158, whether it be inches, miles, feet, whatever we're talking about, 158 units. Let me know if you have any questions when you get to class tomorrow.